You plug in, you walk away, then your EV pauses mid-charge and leaves you staring at a blinking light. What just stole your minutes and dollars? Today we break the silence on charging pauses and invisible energy thieves that quietly drain your charging session. We'll explain the exact reasons your car stops charging, from connector hiccups and handshake failures to power-hungry thermal systems and infotainment vampires, and give clear, practical steps you can use to stop the waste and get back on the road faster. By the end, you'll understand what's really happening when the charger goes quiet, how many kilowatts those hidden systems actually take, and how to manage them so your next charge doesn't get dropped. You arrive at a fast charger, plug in, and expect a quick top up. Instead, the screen shows charging paused, or the car reports charging interrupted. Sometimes charger shows it's delivering power, but the battery state of charge barely moves. Other times, the session drops to trickle charge or stops entirely and won't resume until you reboot the car or swap stations. These are real, common outcomes with clear causes. Troubleshooting documents and network support pages list connector faults, EV software timeouts, and thermal limits as the top culprits. The two classes of thieves, interruptions versus parasitics. There are two big families of problems. First, the interruptions. Events that make charging stop for safety or communication reasons. Think loose pins, bad cables, charger firmware quirks, or the car and charger failing the digital handshake. These are often binary. Charge stops until you fix the connector or reset the session. Support pages and user reports show that these are frequent causes of mid-charge halts. Second, the parasitic loads. Ongoing power drains that quietly reduce net charging power and slow your top up. These include thermal management systems like battery heaters, coolant pumps, cabin HVAC, infotainment, and displays, 12-volt electronics, phone charging, and even sensors that stay awake during charging. These loads don't always stop the charge, but they still useful kilowatt and can make a fast session take significantly longer. Industry analysis show these parasitic systems as a major component of real-world charging inefficiencies. How much power are we talking about here? Let's get concrete with numbers, because it's draining power doesn't scare anyone, but it's stealing 2 to 4 kilowatts does. Thermal management and preconditioning. Battery heaters, PTC cabin heaters, and active thermal pumps can each draw between a few hundred watts and several kilowatts. Manufacturers and lab data show battery or cabin heating can be multiple kilowatts. NRL documents PTC cabin heaters around 5 kilowatt in some systems. And the community tests report preconditioning draw up to 4 kilowatt in certain vehicles during extreme cold. That kind of load can cancel out a common public charger's lower power delivery or dramatically reduce net charging speed from a big charger. Cooling and coolant pumps. Coolant pumps and fans used to stabilize battery temperatures while charging typically draw a few hundred watts to maybe 1 kilowatt under heavy load. Those numbers add up when the battery requires active cooling during a high-power DC session. Infotainment, displays, and 12-volt loads. Modern infotainment stacks and digital clusters can draw anywhere from 50 to 250 watts depending on the brightness, processors, and accessories. Phone wireless charging, lights, and small accessories add tens of watts more. While these are small compared to HVAC, they matter when the charger power is constrained or when many parasitic run at once. Net effect on charging efficiency. Real-world measurements show total charge chain efficiency commonly is in the 80 to 90% range, and auxiliary loads and round-trip inefficiencies can make the difference between a headline kilowatt number and what actually reaches the cells. Recurrence analysis and other studies show charging losses increases at the high state of charge and when parasitic loads are active. In practice, the combination of parasitic loads and thermal limits can increase your 10 to 80% session time by 10 to 30% or more in some conditions. Why pauses happen in the middle of a session? Charging pauses are often safety or control actions. The car's BMS or charger detects the condition and says stop. Typical triggers include thermal limits reached, the battery or power electronics heat beyond the safe thresholds, so the BMS requests a pause or limits current until temperature falls. Thermal management systems then run, consuming power and sometimes leading to a cycle of slow charging or multiple stop and starts. Communication errors. The digital handshake between the charger and the vehicle can fail or time out if the charger firmware and vehicle software disagree, or if noise or voltage transients occur on the cable. The station may pause to protect itself or to retry authentication. Connector or hardware faults. Corrosion, a slightly loose latch, or a damaged pin can cause arcing. Chargers detect arcing or unexpected resistances and shut down instantly for safety. These are common in public networks with heavy turnovers. Low 12-volt battery or system issues. Some cars will refuse or interrupt charging if the 12-volt system voltage is out of range, because many control systems and relays rely on stable 12-volt. Forums document cases where a drained 12-volt battery caused repeated charging interrupted messages. All of those are fixable, but the challenge is identifying which one fast. Drivers often waste 20 to 60 minutes rebooting and retrying, while the real problem is a small connector or an HVAC load that could have been managed. Imagine a 150 kilowatt DC charger is connected to a car that, due to cold ambient temperature, needs 3 kilowatt of battery and cabin heating while charging. That 3 kilowatt is either taken from the charger or from the battery if the charger power is limited. If the station is delivering 50 kilowatt because of the car throttling or grid limits, subtracting 3 kilowatt of parasitics take you down to 47 kilowatt net. And that lowers the energy you gain per minute, stretching a 20-minute session into a 22 to 25 minutes. In colder scenarios with heaters closer to 4 or to 6 kilowatts, the impact is dramatic. Some low power chargers can't keep up and the pack must supply the deficit, causing state of charge to stagnate or bounce and triggering safety pauses. Community tests and manufacturer notes back this up. Drivers report sessions where the charger shows power out, but the vehicle's state of charge doesn't rise because the car is simultaneously using energy to heat the pack or cabin. Reports and diagnostics threads point to a cycle where the car stops the charge, starts thermal management, state of charge dips slightly, and the car requests charge again. And the station starts. Then cycle repeats, a frustrating loop that wastes time. Troubleshooting support pages and community threads show this pattern worldwide. How to stop energy thieves and manage pauses. Immediate actions at the charger. Check the cable and connector seating. A quick unplug and reseat often fixes marginal contacts. If you see visible dirt or corrosion, move to another stall. Many pause events are basic hardware issues. Watch the temperature indicator and BMS messages. If the car warns of the thermal limits or show active preconditioning, note the charger is competing with heaters or pumps for power. If preconditioning is running, letting it finish before you connect often avoids a hamstrung session. Turn off unnecessary loads during charging. Dim displays, close climate controls if you can, unplug phone or Wi-Fi chargers, and ask passengers to keep electronics off. Those modest steps save tens to hundreds of watts and matter when the charger is near your car's sustainable limit. Routine habits that prevent pauses and waste. Schedule charging to finish near your departure time. This avoids long idle periods where the parasitic vampire loads and thermal systems can run mid-charge and cause odd state of charge behavior. Off-peak scheduling also reduces the likelihood the charger or the grid is in a protective throttle mode. The precondition en route when you plan to fast charge, use navigation-based preheat or so the battery is already in the optimal temperature window on arrival. That prevents big heater or cooler draws during actual charge. Tests show preconditioning can boost early sessions power by 30 to 50% and shave minutes from a stop. Keep the 12-volt battery healthy. A weak 12-volt supply triggers odd charging behavior and some interruptions. If you notice frequent charging interrupted messages, have the 12-volt system checked. Forums and service notes document this is a common hidden cause. Update vehicle and charger firmware. Many handshake and timeouts issues are fixed with OTA patches or charger firmware updates. If a specific station gives repeated trouble, report it to the operator. They may need a firmware refresh. Charging pauses are rarely magical. They're either safety stops triggered by hardware or software, or they are the result of parasitic loads quietly stealing net charging power. Thermal systems can eat kilowatts, small electronics hundreds of watts, and together they turn a fast 20-minute stop into a slow half-hour slog. You can fight back. Precondition the pack, minimize loads when charging, keep connectors clean, watch the BMS messages, and keep your 12-volt healthy. Those habits reclaim minutes, save energy, and stop you from being a victim of the silent energy thieves. Want a one-page checklist to pin to your phone for every fast charge stop? Click on the link in the description. You can download a free PDF.